Good afternoon, ladies and gentlemen of Algebra 2 Honors. Welcome again to room 15, where?
Learning never ends.
Learning never ends, thank you. So we left it off on Friday that Madeline was we kind of ran out of time when Madeline was about ready to do number 4. So she's going to be able to do that for us, give us our domain, range, and behavior, and state the degree of the function. Yeah, and it says check in a graphing calculator, right? So that's what she appears to be doing right now. There's a calculator that doesn't work?
Well, I don't know. I couldn't do it.
Which one?
I'll just use mine. I don't ever use those.
This one here?
Yeah, I'm sure it works fine.
Yeah.
No.
Mr. G, I asked if I could go with that.
Okay, Madeline, whose name is there? Who's working this problem right now?
Me?
So is that the time for that to happen?
Well, no, but.
Okay.
Oh,
I see what it is. Yeah, the thing you had here, you had a minus instead of a negative.
8th grade, I go, you weren't even in middle school.
Yeah.
I didn't know, I'm just right now. And you were Tyler, you were senior reading. I don't know, something about the grades. I said something about, I something I did, and he was like, oh yeah, this is, and I go, no, you're thinking too late, because you were in high school already. And he goes, how do you know? I don't know this class, and I was like, oh my God, your grade wasn't me. I'm in this class, and I don't know what happened, and I go, I don't know this class, and I was like, Ratty just goes, how it goes, and the grade was not really known, right?
Like me? Could a domain be negative infinity? Negative infinity?
No.
I don't know how to do this.
Negative infinity.
Well, that's not what it is.
I don't know. Oh, I copied that one. I accidentally wrote that one here.
Well, Mr. G,
I wrote on form.
Yeah.
I'll just make a little guess and then.
Okay, yeah, go ahead.
Yeah.
That's part of what we do in math, make guesses. What do you have? What is your domain going to be?
I actually have 0, negative infinity. Pretty sure that's wrong.
Yeah, for domain, that would be wrong.
Is it right for range?
Domain?
Yes.
Domain is.
Okay, so domain, I'm going to do negative infinity to infinity. And
Okay.
then range is 0 to negative infinity.
Okay, so range, she said 0 to negative infinity like this. Is that right?
You have to do a little box thing on the 0 and then the
Box on the 0, okay. So like that?
Yep, just like that.
Okay, is that right?
Shouldn't it be reversed?
Yeah, this is, so Bryce is right. This is almost right, except for Bryce, what is it really going to be?
Negative infinity to 0.
Why, Bryce?
So you can start from lowest to greatest.
Yeah, so what it is, just convention. You're starting from lowest to greatest. So that's why you have to, and it's really math convention. I don't want to say that, because this thing that Madeline gave me is not, it's not wrong, because the numbers are right, aren't they? And the limits are right, it's just they're not in the correct conventional interval notation fashion, that's all. Okay? Okay, good. And what about the end behavior?
As x approaches infinity, f of x approaches negative infinity.
Fx approaches negative infinity, okay? Everybody good with this end behavior here?
Yeah.
Okay, good. Let's do the other one. As x approaches
As x approaches negative infinity, f of x approaches infinity.
So what kind of function is this? It's going to be, remember we had this thing, odd, even. So which one is this? Is it this one? This one?
It's both down.
This one? Or this one?
Even, so it'll be negative infinity.
Yeah, so this is start low, end low. Okay, so assuming negative infinity here. Okay, and then the last thing is what degree is this? Degree is what?
8.
Degree of 8. Okay? All right, thank you for your help on that. Pardon me? Okay. So,
What are you talking about? No, go to 1 equals, and then do x, like the one we just did, is to the 8. So you can do it. Yeah.
okay, we're going to go on to number 5. And number 5, it's really kind of a different thing we're doing here. And it says to use the calculator. What I want to do is I want to show you how to do these without a calculator because it's really a helpful thing to know. So I'm going to go ahead and take you through the process of how to sketch the graph of these. And then we're going to, basically, you're going to find the number of turning points and the number and type of the turning points of any maximum or minimum values. So basically it says use the graphing calculator to graph the function, but I'm going to show you how to do this to sketch the graph without a graphing calculator. And you can use the graphing calculator to do what? Check. Does it look right? Does what I'm about to do now, is that more or less accurate as far as what you graph on your calculator? So first thing I look at here is I count how many x's you have multiplied together. So how many x's are multiplied together here? 3 of them, right? So I know, even without expanding out, I know that our leading term is going to be x cubed. And then it's going to be plus or minus something like that, right? I don't know what it is, but what is x to the third power? What does that let me know about the function? It lets me know what kind of behavior? The end behavior, thank you. And again, the end behavior isn't how you act just before you're about ready to pass away. Nobody laughed. Oh, very good. Thank you for giving me a little fake laugh there. I appreciate that. Okay. Anyway, so what it is, these number of x's, that means those are the possible number of zeros we have. And how do we find what the zeros are to help sketch with the graph? what we do is you set this whole function equal to 0. So you have 0 equals x times x plus 1, quantity x plus 3. And how do you find the zeros from here? How do you find the zeros from here? You have 3 factors, and I call this, by the way, I call this factored form. They call it intercept form, but this is what I call factored form. Because the equation, the function is written in terms of the factors of this. So what you do is you set each of these factors equal to 0. It's called the zero product property or zero factor property. So for this to be a true equation, x can be equal to 0, right? And also you set the other factors equal to 0. So you have x plus 1 equals 0, and you have x plus 3 equals 0. And then you solve for x. So x is equal to what?
-1.
X is equal to -1, and x is equal to -3. And so these are the zeros of your function right here. So you go like this. So I'm just going to go ahead and make a little sketch like this. And you may have already done this with your calculator. What you do is you mark the location of the zeros along the x-axis. So here I put down -3 over here. I'm going to put -1 over here and 0 over here. And so those are the zeros. Now based on x cubed, are we going to start high, end high, start high, end low, start high, end high, or start low, end low? Which one is going to be?
Start low and high.
So how do you know start low, end high? By the way, that's right. How do you know that?
Because it's going from negative
Because you have odd positive, right? Odd positive. That's it. Start low, end high. So we don't know exactly what it's going to do, except we know it's going to start low and it's going to end high over here someplace, right? So start, end. So we have the function starting from negative infinity. Remember the range that Madeline gave us before, or was negative infinity to 0. Well, here our range is going to be negative infinity, positive infinity, right? We're going to start low, end high. So what it is, you come up all the way from negative infinity, and what happens at -3? What happens at -3? You cross the x-axis.
Oh.
And then you go up here, and what's going to happen here at -1? Is it going to cross the x-axis?
Yes.
Yes. And it's going to come at 0. It's going to
Cross the x-axis.
cross the x-axis,
And I'll
right?
say, Mr. D, I typed in the calculator and that's not what my graph was on.
Really?
Really?
Okay. Let me see. Your,
Oh, yes, it is. I'm lying.
it is, yeah.
I'm lying.
And part of it depends on how the scale of your calculator is, right? So that's what it looks like. And then you look at the number of turning points, and how many turning points do we have here?
1, 2.
2 turning points. And then it says the type of turning points, right? It says you have 2 choices. You have global, that's one possibility, or local but not global.
Local, but not global.
Yeah, are there any global extrema here? No, there aren't. Why not?
It only goes up to 3.
No, the reason is the range is not limited, right? The range is negative infinity, positive infinity.
Right.
So when you have that case, you don't have any global maximums or minimums. And so you have 2 turning points, and so you have 2 of any maximum. So we'll say we'll have 2. We'll call them local, but not global turning points. Yes, and one of them is a minimum, one of them is a maximum, right? One minimum and one maximum here. All right, so what I'll do is call somebody for number 6. How's that? Can you go ahead and work on that? I'll call somebody in a minute.
Yeah. You're calling somebody?
Okay, I'm gonna go ahead and erase this to leave room. And when you graph this in a calculator, did you see something like that? Is that what it looked like? Carly, is that what you got when you graphed it? Looked about it. And somebody in the sixth period was asking me, how do I know it looks like that, kind of? Well, how do you know how far up it goes and all that? Guys, it's just, it's experience. I've had so many years doing this that I have more of an intuition of what it's going to look like. And is my intuition always right? No.
No.
But it's right a lot. Oh, 6. We're going to do 6, right?
How do you do x plus 1?
Yeah, so you set those factors equal to 0.
I know, but how do you do the square?
Yeah, so what you're going to do, whenever you put this all in place, you'll have x squared times x times x. So you're going to get x to the 4th plus something. That's what that's going to be. And by that x to the 4th, what do you know? What can you find from that?
4 things.
Are we starting high and ending high? Starting low, ending low, starting low, ending high, starting high, ending low. Okay, that x to the 4th is what drives what kind of end behavior there is. Okay, number 6 we have Brian.
Caught it.
I remember Brian, he did a good job last time, I thought.
I had plans to just go
So I think in 6th period, I think Caden had this one.
Oh, no, it's missing. Went too far.
that was a little far. I feel like the ball.
You don't. See, no.
Because if you're not.
Yeah, you know how the heater works in here, don't you? Did I explain how the heater works? I want to explain it once.
Wait, what?
Okay, we have a thermostat that is set to keep this thing in a temperature it's like 69 degrees and 72. What happens is the temperature will get up to 72, like the heater's on right now. Right now it says 69.5. When it gets up to 72, it's going to shut off, but it's going to blow hot air until it shuts off. And then it's going to cool down to about 69, and then the heater will be off, and then it'll come on again. And so the problem is that when it's heating, it's going to blow hot air into the classroom. And while it's doing that, maybe it'll be a little bit warm.
Can't you override it though?
Well, I can't override it. I can do some overriding, but not, I don't think I can override it in a way that will help us.
Gotcha.
That's what I'm saying with this. And you see, it has to be that way, right? Because if it didn't, it would just get way too cold.
Yeah, it's really cold in here.
And that's a similar type of thinking when it needs air conditioning too.
Oh, mine is definitely 80.
Yeah, there's another thing that's an issue here too, Carly, and that is that over here on this side, I'm closer to the windows, which when it's cool like today, it'll be cooler on this side of the classroom than it will be on the other side. It's just like the best we can do, which fortunately is pretty good.
Like on the real stuff. No, on the real stuff. No, I'm just trying to get it taught. That's what I think, that I'm like, I'm understood. Yeah.
How do you know it's just
Now on this number 6, are you going to start high, end high, or what are you going to do? Or start low, end high? What are you going to do with this one?
wait, there are 4. I told you there was 4.
Remember your stapler?
X equals 2, right? It's going to be number X.
Isn't that a nice warm stapler?
I know.
Yeah, it's this computer that does it.
Mr. G,
Yeah.
can I show you like, what I got so far?
Yeah, oh, sure. Let me take a look here.
Yeah.
I gotta get to the side here. Yeah, so you have the zeros of x equals, okay, you got x equals -1, that's a 0. And x equals, then you gotta do, you gotta have,
Yeah, I know, I just, that's how much it gets to me, it confused me at that point.
so you got that one, x equals 0. No, x equals -1, you got that, right? Okay. Then you're gonna have, you got x minus 1 equals 0, so x is equal to 1. You have x is equal to 2. Okay, so what are you gonna do like this? It's gonna start high, end high?
Yeah.
Start high, end high, right?
So, maybe, I think it's gonna, I'm not sure, Mr. G.
Okay, can we please turn off the devices? Is that too much to ask? So anyway, so you go like this, and we just, so mark those zeros, mark them here at -1, 1, and 2. So mark -1, 1, 2, just mark it there. So I'm just going through the process of showing how. Okay, so the heater went off now, right? So now the room is cooling, right? So you got right, actually got above 73, so you got up pretty warm. And it's going to cool down until 69 or so. Okay, good. So he has these drawn, right? And Brian says it's going to start high, end high, right? Is that right?
Right.
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 So let's go ahead and take this. So we're gonna start here,
Start high.
end here. So what I want you to do here, and that is, this is one with a multiplicity of 2. So what you're gonna do is you're gonna bring it down here, you're gonna bounce off this x-axis, and come up here, go down through here, and down up through there. So he's gonna, so start up there, hit that x-axis, bounce up, bounce up.
Oh, right here. Oh, right here. Let me show you this.
And you come down here,
Yeah.
bounce. Okay, so you're gonna come up here. So we'll finish that. So finish that there, come up here, go down through here, go down below that x-axis, go to this 2, go up there. Yeah, there you go. That's it. Oh, very good. Okay? Does that look about right? Does that look about right?
Yeah.
Good, right?
Let's see.
So how many, so just put down, how many turning points you have there. Just write down, count your number of
1,
turning
2,
points.
3.
And also if they're low, what kind of turning points they are.
A W. Local. They're global.
Do we have a global one here?
No, I think that is all of them.
No, we do have a global,
Oh.
right?
So we have one global, two,
2 local but not global. So go ahead and write 3 turning points, 1 global. Yeah, I'll put that.
yeah.
Okay, so 3 turning points,
2 local and 1 global.
3 turning points, 1 global, and 2 local but not global, right? Bryce, is that what you were telling Brian?
I didn't really figure it out.
Oh, you didn't? Okay. But does this make sense? Does it look like the one you graphed in your, did you graph in your Lily, did it look like you graphed in your calculator like this?
Yep.
Okay. Okay, questions on that one?
Top of it.
Questions on that one? Okay, I appreciate you working on that. I'm gonna get, go ahead and work out number 7. I'll call on somebody for number 7 here shortly.
Can you just say my name? You said you were gonna make me.
You know what?
Are we still on the topic? You were?
I didn't must look at it as global.
It was even topic of the video.
Okay, global means
Yeah,
like,
but
let me
it's
show
not
you.
true.
Okay, Michelle's asking a question about what does it mean by global? Okay, for global means we look at the whole, we consider the whole function. Everything, everywhere, right? So if we look at the whole thing, is there something that is absolutely the highest or absolutely the lowest point here? Yes, there is, right here. So that's why we call it global. You gotta consider the whole thing. Also, you can call it sometimes absolute. And so this is the absolute lowest point, and so this is what we call a global minimum. These other ones here are local minimums and maximums, but they're not global because even though that's a minimum, it's not the absolute minimum because this minimum is lower. Does that help with what that is? Yes. Okay?
So you can never have 2 global.
The only way you could have 2 global, that's a good question, okay? That is a really good question. Okay, yes, for a polynomial function you can't. But can you imagine there's a type of function where you have 2 globals? Yeah, like the sine function. If you have something like this, it just goes like this and keeps on going like this forever. Do you have two globals? Yeah.
But would they not just be two locals since they're the same?
Well, they're all locals. All these are locals too. Every type of minimum and maximum is a local, right? Because what local means, you look at the microscopically. You take a microscope in this area, is that the lowest in that? That's a local, okay?
Oh, so it's kind of like a
All right, Michelle, that was a good question. Okay, this one right here, for 7, if we go ahead and multiply all these x's together, we're going to get negative x cubed.
I'll use my board.
I'm serious.
And then it's going to be plus something something, we don't know yet. But what does that negative x cubed get you to do? It helps you with what? What does that negative x cubed number 7 help you to do?
Point there.
It tells you if it starts high, ends high, starts low, it tells you the end behavior. Okay, that negative x cubed tells you the end behavior. So even before you graph in the calculator, you know where the thing starts and ends.
Oh, yeah, I'm sorry, I had a brain fart. Like,
Okay, number 7 we have Carly.
Carly. Like Carly without the H?
Carly on the west wall, right there. Friend of Madeline, friend of Bryce, friend of everybody. Basketball teammate,
She quit basketball.
friend. You did? No, you didn't.
Yeah, like what do I do?
You divide it by.
So it's x equals to, this one's good.
Oh.
Oh, there's a cute little thing right now.
Or we don't have two of them that are actually.
Why do you do 2? Well, that makes sense. So it should be x equals 2 twice. So that's like, we don't make
Yeah.
it. Okay.
Well, it does affect your point, right? So you have 3 after. So if you have the negative. Oh, no,
All right, let me go ahead and adjust the board because the thing just gets out of alignment so easily on us. so she's setting her function equal to 0. You're going to find her zeros here.
Carly, who'd you go see Scream with? So stupid, I can hear the whole time. I know,
Okay.
I was asking him to do a question.
And what kind of one? So you saw the algebra, and also one thing that I liked that she did was she actually recognized that this meant 2 zeros. And even though they're the same 0, that's a double 0. What happens in a double 0? That's where you touch but don't cross the x-axis. So it's called a 0 with a multiplicity of 2. We're going to go into that later. And these are what kind of zeros? Local, but what?
Yeah, I didn't know the local or anything.
But not the local. I want to ask you, Carly, on this one. Did you use your calculator to help you with that too?
I did. I helped with the graph.
I'm glad you did. Good work. That's good. That's smart work. I'm glad you did. Questions on that? Okay, good. Okay, ladies and gentlemen, we're going to go ahead and just go to, I want to talk to the class here before we go here.